Okay, this is the mechanics units notes for robotics 2. In this unit, I want you to be able to use mechanical advantage to calculate torque, use mechanical advantage to calculate linear speed, find the traction of a wheel, calculate the torque needed to move a lever arm, and calculate the efficiency of a robot. All right, so getting us started here, we got linear kinematics. Kinematics is a study of motion, and we're going to primarily focus on 1D problems, so objects moving in a line. We'll also need to take a look at projectile motion, 2D problems, but we'll get there in a minute. There are two types of motion, constant velocity and constant acceleration. So for velocity, so the object's going to move without speeding up or slowing. So what that means then is that the acceleration equals 0. If I were to make a position versus time graph, we would see that it would be a linear relationship of velocity versus time graph, be a horizontal line, and an acceleration versus time graph would be 0 because the acceleration would be 0. Okay, in constant acceleration, the object's velocity will change uniformly. So in this case, the acceleration would equal the final velocity minus the initial velocity over time. So if I were to draw a position versus time graph, this would cause a curve to appear. On a velocity graph, since it's changing uniformly, we should see that linear relationship. And then on the acceleration graph, we should see a constant non-zero acceleration. Now, it's very important for us to understand the difference between acceleration and velocity. So as an example, what is the acceleration of an object that has been thrown vertically into the air? Well, once you throw something up, as soon as it leaves your hand, it starts to slow down. So that means it's accelerating, a negative acceleration. And as it turns out, its acceleration is going to be negative 10 meters per second for every second. Skipping one down here, what is the acceleration of the object as it falls back to Earth? Well, it's speeding up. It's getting faster, but it's moving in a negative direction. So once again, it's going to be our negative 10 meters per second per second. All right, now for this one. What is the acceleration of the object at its highest point? Well, it has to stop. And that makes people think that the velocity, since the velocity is 0, the acceleration would be 0. But that's not true. If the acceleration were 0, that means the velocity would not change. And if the velocity doesn't change, that means the object would just hover. So believe it or not, the acceleration at its highest point will be negative 10 meters per second once again. All right, so for our types of motion then, we have these three equations which help us out. And they're universal for constant velocity or constant acceleration. Just remember, whenever you have constant velocity, the acceleration equals 0. If you remember that, you can use these three equations for constant velocity or constant acceleration. Okay. Now, projectile motion. This is the study of objects as they fly through the air. and the only influence is going to be gravity. So we're going to ignore air resistance. So to begin with, we need to understand that velocity is a vector. It has magnitude, usually feet per second or meters per second, and it also has a direction. We represent it with an arrow, such as this arrow here. Now, if this right here is the y-axis, and this is the x-axis, we can see that this velocity vector is being launched at some sort of angle. That means that we can take this and break it up into its x and y components. I would have a y component. And I would have an x component. And that's how I would calculate the two. What this means then is that we can isolate the velocity into its x direction and its y direction independently. Now you may be wondering where I got the sine and the cosine at. That's where we have to start talking a little bit about trigonometry. Now we do have something called SOHCAHTOA. This means that sine of an angle equals the opposite side divided by the hypotenuse. Cosine of an angle equals the adjacent side to the angle divided by the hypotenuse. And tangent of an angle equals the opposite side divided by the adjacent side. So looking at this triangle here, sine of A would equal capital A over H. And if I were to do some algebra with this, cross multiplying, I would see that A would equal H times sine of that lowercase a. So that's how I calculated this Vx and Vy up here. I saw that sine of theta equaled Vy divided by V. And then when I cross multiplied, I was able to get on my equation for Vy. And then I did the same thing for Vx, except I used cosine. All right. Something else that we can use is the Pythagorean theorem, where side A squared plus side B squared equals the hypotenuse squared. All right, so in projectile motion, velocity along the x-axis is constant. So for this v naught x here, it stays constant. So that means that on the x-axis, the acceleration is 0. The y-axis sees an acceleration. So the acceleration on the y-axis equals g, which is our negative 10 meters per second squared. If you're using feet, this is also negative 32 feet per second squared. Now, using that, we can go ahead and use these equations here for our projectile motion. I'm not going too far in depth with it because this is more of a topic that I save for my physics class. So being an engineering course, I just want to provide you with the tools you need to get some basic problems underway. And when we take a look at problems to solve in class, these formulas they'll become a little easier to use. All right, that concludes video 1.